Hi, welcome back to Make Sense of Math. I am Michelle and I am so glad you are here with me today. Today I want to talk about the best method to teach exponent properties so students aren't just relying on memorizing, because if they are just relying on memorizing and they don't have it memorized, they're not just stuck. I'm going to focus on 3 exponent properties today: the product of powers, power over power, quotient of powers, and I am also going to talk about a number to a zero power. But I mostly want to focus on the method that I teach it so that you can apply it to all the exponent properties. So before I even talk about the exponent properties, I always review 2 facts with them. First of all, the first fact is, what is an exponent? We review just the basic, what does 2 to the 3rd power even mean? And we go over that it just means 2 multiplied by itself 3 times, right? So this is something that we review with them. And then I also review with them that a number, let's say 2 divided by itself, will always equal 1, right? It's a basic fact, but it's something they need to understand in order to mostly understand the quotient of powers. So what we do is, when we start this, we're going to start with product of powers. If I have, for example, x to the 3rd times x to the 5th, right? We talk about, what does that mean? The first step is we make sense of the problem. So x to the 3rd, and we're going to write it out. X to the 3rd is the same as x times x times x. X to the 5th is the same as x times x times x times x, right? So we have made sense of the problem. And then I ask them, is there a different way to write this? Like a simplified way. And we're going to talk about it, and somebody's eventually going to say, that's the same as x to the 8th. We say, all right, so x to the 3rd times x to the 5th is the same as x to the 8th, right? And I give them probably like 5 or 6 more problems, and I keep all the information on the board. So I don't erase it, because the next thing I want them to do is to look for patterns. So we're going to have a bunch of these expressions, or I guess equations, up on the board. And I'm going to say, is there a way to get from here to here without having to do this, right? This will always work. It will always give you the right answer if I'm writing it out, but it's not the most efficient way, right? I'm not always going to be wanting to write out all my exponents, although I could if I needed to. Again, it's just not very efficient, especially when we have large exponents. So we look for patterns. How do I get from here to here? Is there like a shortcut, or is there like a correlation between these numbers and these numbers? They're going to eventually get that if I just add those, like 3 plus 5 is 8, and maybe if I have more examples, maybe 2 plus 4 is 6, and I have all these different examples, I'm going to say, okay, so you think that if I just add these exponents, it's going to give me the same answer. That's the hypothesis, all right? And then we try it out. We give more problems, and I say, okay, try your strategy first. So I say, write what you think your answer is first, and then go backwards and check it. And then they will say, oh my goodness, that works, all right? So I say, okay, so then we write the generalized form. We might say a to the b times a to the c is the same as a to the b plus c. So we do go back to the generalized form, but we have made sense of it. We've proven it, right? So then let me show you an example like this with the power of a power, right? So if I have x to the 3rd to the 4th power, right? We make sense of it. We write it out first. X to the 3rd to the 4th. So I say, okay, x to the 3rd is the same as x times x times x, right? That's the same as this. Now to the 4th power means I'm having this multiplied by itself 4 times. And I make them write it out. So we have that written once, twice, 3, 4 times, right? And I say, is there a different way to write this? And they'll say, oh, that's the same as x to the 12th. So we write this up on the board. I write it like this. And then I give like 5 or 6 more examples. I don't erase the work because I want them to look for patterns. So once we do 5 or 6 examples, I say, okay, is there a pattern here? Is there a way I can get from here to here without having to do this? Again, this will always work. It's going to give me the right answer, but it's not the most efficient. And so then they will notice, oh, well, 3 times 4 is 12. And so then we test their hypothesis. I give them another problem, maybe like a to the 5 squared. And I say, okay, well, what's a to the 5 squared using our hypothesis? And they say, okay, well, I think that's going to be a to the 10th. And then we check it by writing it out. And then we write the generalized form. Maybe a to the b to the m is the same as a to the b to the m, as for an example. Now, the reason why I do this is so that when students start working on the simplifying exponents and they say, I can't remember, I say, write it out. I don't tell them the rule, I just say, write it out, and then they can figure it out, right? And they're gonna eventually start remembering the rule once they get it practiced. But this is a way for them to figure it out. Say, okay, so quotient of powers. If I have, let's say I have x to the 5th over x cubed, right? We write it out. X to the 5th is x times x times x times x, and then x cubed on the bottom we write out. So it looks like this. All right, and then this is where we have to talk about how a number divided by itself is 1. So if I have x divided by x, and this shouldn't be new in like in 8th grade or algebra when you're teaching this, like concept of canceling shouldn't necessarily be. So x divided by x is 1. Now I can write 1 times that number, but it's not going to change that number, right? It's going to give me the same answer. So I'm just going to cancel it out. Cancel, cancel, cancel. And then I have x times x left on the top, which is equals to x squared. Again, so I do 5 or 6 more examples. Sorry, I should have written this up there and reverse those. And then I ask my students, okay, is there a way to get from here to here without always having to write it out? Again, it's always going to give me the right answer. It's just not the most like efficient way to do it. They're going to eventually realize that if I minus the exponent, it's going to give me the same answer because they've looked for the pattern data for their hypothesis. I give them another problem. They do their hypothesis first, and then they go check it. And then they're so excited that they're right and they figured it out. And then we write the generalized form. Let me show you how I do negatives. You're going to need to give them a table. All right, let me show you how I do this with negatives. So this will show them negative exponents and to the 0 power. I started with a table, right? And we're going to look for a pattern with this. So 2 cubed, we're going to start filling it out with what we know. Students know 2 cubed is 8, or if they don't know that, they can figure it out. 2 squared is 4, 2 to the first is 2. That's everything we know. And then we notice that 8 divided by 4 is 2. All of this is getting divided by 2, right? So the pattern there is when I go down an exponent, I divide by 2, which is the same as my base here. So I'm dividing by my base. So I'm going to continue the pattern, divide by 2. So 2 divided by 2 is 1, and I'm going to keep dividing by 2 here, and we're just going to continue the pattern. So 1 divided by 2, going to give me 1/2, keep going, 1/4, and 1/8. Again, when I do this, I do it, I might even do it down to the 10th. Like I do it extreme so they can see that the pattern's always consistent. And then they start noticing that they are reciprocals, right? You look for the pattern. And then we talk about, okay, is the number to the 0 always 1? And we do it with different bases and check it. And then they notice that it is, and we talk about why, because you're always going to be dividing the base by the base at this point, and it's always going to give me 1. And then we go on and check it. So I am showing you one example, but remember to do multiple examples. So I do 0 exponents and negative exponents with tables. So that's kind of like the process of the procedure that I go through with teaching exponents. We make sense of it. We look for patterns. We look for a shortcut, kind of create a hypothesis, go back and check the hypothesis, and then write a general rule. I have notes of this with my 8th grade math guide and notes. Exponent properties, I have one for every property and all the tables. It's all done for you. It gives you space to analyze it, make sense of it, and then practice it. There's a handful of notes. This is just showing you the product of powers one. Anyways, so that is my favorite way to teach exponent properties. It's honestly very effective because students have a way to go back and figure it out if they don't remember. And when they continually practice it, they're going to retain the information. And thank you for being here today. I would love for you to subscribe and share this with other middle school math teachers so we can also help them to make sense of math. Have a good one.